it as an array of vectors. So how would you represent this graph in adjacency list? So like 0 is your node. So 0 index will be pointing a vector. So your vector will contain only 1 because 1 is the only node which is connected to 0. Okay. Now, if I talk about 1, so in array at 1 index, I will be having a vector which will be having node 0, 1, 2, and 3. Okay. So this is clear to everyone, right? Okay.
One will
So let's
not be
move.
there, right?
Oh, sorry. Okay. So only 0, 2, and 3. So, so can anyone like give an approach, like how would we do it if I start from node 0? So if anyone is having some approach, like this approach can be done to solve this problem. It needs not to be perfect. Like if you are having something, you can say. If anyone has any approach, they can unmute themselves and speak.
What we can do is we first maintain a visited array of length of
Okay.
the length will be the number of nodes.
Hmm.
Then we start traversing from that 0.
Okay.
From 0 we traverse, and when we traverse, if we while traversing, if we uh, come back to some node which has already been visited, then we know we have a cycle.
Okay. It is partially correct. Like you have given a thought. It's good. It is partially correct. So now, like if you are coming to this node, okay, you have visited 0. Now you come to this node 1. You will go through the adjacent nodes of this. So 0 will come. Now, according to your approach, 0 has been visited. So you would say there exists a cycle, but there does not exist a cycle between 0 and 1. So let me give you a hint. So if I am reaching this node 3, okay, so I have two adjacent nodes, 1 and 2. So suppose first I visited 1, then I moved to 2, and then I moved to 3. So can you tell me one difference between 1 and 2 in relation to 3?
So we are moving from 2 to 3, but
Okay.
from 3 we have not moved to 1 yet.
Yes. 1 and 2 have been visited and you are at 3. So I want that you tell me the difference which 3 would see between 1 and 2.
The 3 will see that its parent is 2.
Yes. So that is the crux of this problem. So what we would do, so along with the that visited array which you are maintaining, you will maintain that parent element also. So if you are having an adjacent node
If it
which
is
has
not the
been
parent,
visited,
the visited, then we have a loop.
yeah, you got it. So
Okay.
everyone got this. If anyone has any problem, you may unmute yourself and speak. So let me repeat. So when I visited 0, then I moved to 1. Okay. So 0 has been visited. Then I came to 1. Now 1 will see 0 as its adjacent node. But 0 has been visited and it's not, and it is equal to its parent. So 0 was the parent now. So we are tracking like 0 is the parent of 1. So this doesn't show like there exists a cycle. Now we move from 1 to 2. Now 2 would see 1 as its adjacent node. Now 1 is the parent also, and it has been visited. So we don't say like there exists a cycle. But when we move to 3, now 3 would see 2, 2 has been visited, but it's his parent. So nothing would happen. But when 3 would see to 1, so 1 has been visited, but 1 is not the parent. Then we can say that there is a loop in the graph. So is this approach clear to everyone?
Yes, sir.
कुछ yes no बोल दो यार.
So,
चलो फिर कोड देखते हैं एक बार. इसको हम इसको मतलब कोड में कैसे रिप्रेजेंट करेंगे. ठीक है, तो पहले अभी हम देखते हैं BFS अप्रोच. Does anyone have any problem with the Hindi or English?
No.
Okay. Now, is everyone able to see my code?
yes.
Yes, sir.
Okay. So you see V is the number of nodes, and this is array of vector which I was talking about. So this is your adjacency list. So now what we are doing is we are traversing through each vector and we are maintaining a visited array to track if the node has been visited or not. So first we would start with 0 node, then we would come here at your BFS. So the normal code which you must have written, like you used to create a queue. Okay. So, but this time we are going to maintain a parent also. So we are passing a pair here. Pair of what? Node and its parent. So when you are passing a value in this function, so it does not have a parent. So we pass -1 here. Now this source has been visited. So we do the general loop which we used to do in the BFS. So we are running this loop and we are obtaining the pair out of that front value from the queue. Now we are traversing through the adjacent nodes and we are checking if the node has not been visited. Then we are just pushing in the queue like we used to do in the BFS. But the parent node, but we are putting the current node which is in the loop as its parent. Okay. If the node has been visited, then we are checking if the visited node is a parent. If it is not a parent, then we are returning true, means that the graph contains cycle. So everyone got the approach? Hello.
Yes.
Please repeat.
Okay. So what part you were unable to understand? Hello.
How are we getting the cycle?
Okay, so cycle part is first you need to understand the basic. We can write the code later. So up now you are at the 0th node. Okay. Now you are running BFS. So what you would do, you would push this. Now you would push all the nodes which are not visited yet in the queue. So one has not been visited. I will put it in the queue. Okay. Let me make a queue here. Now one is there. Okay. 0 has been out. So now one is there. Now one would come out and I would check all the adjacency nodes. So 2 is the adjacent node. Okay. And it has not been visited yet. So I would put it here. Then 3 is also an adjacent node, so I will put it here. Okay. Now 1 is out. Now you would come at 2. So now you would see 1 is the adjacency node, but it has already been visited. Okay. Now when you come to 3, then you will check 2 is the adjacent node and it has been visited, but it is a parent also, because here in the queue we are pushing the node as well as its parent. So that 0 was pushed with -1. Okay. Then that 1 was pushed with 0 as its parent. Now in the case of 3, when you would check, like 2 has been visited, so 3 would have been like this. Now you will check if 3's parent is equal to this node. So it is equal, so we don't have any problem here. But when you would check this with 1, so 1 has been visited, but 1 is not equal to 2. That means this graph has a loop. Now is it all right? You got it?
Yes.
पक्का ना, ऐसे ही तो नहीं बोल रहे? बताओ पक्का आ गया समझ में?
I
Hello.
didn't understand it in the code actually. I understood the approach in general.
Okay. So in the code, let me tell you. So here, now you started with node 0 as I did in the graph, okay, in the diagram. So 0 has not been visited yet. So I would run the BFS, okay. Now it is the starting node, so I am passing -1 as its parent. Now you came here and you pushed inside the queue the source as well its parent. So for the first one, the parent is -1. Now you would run this while loop like you used to do in the BFS. Like while queue is not empty, we would run this loop. So now you are getting this pair from the front of the queue. So what does this pair contain? This is your node, because I told you we are passing pair inside the queue. So first is the node and second is its parent. So now you are going through all the adjacent nodes of the node, of the current node. So what is it doing? X is all the nodes which your current node has its adjacent. So suppose this is your 1, okay. So current node is 1. So your X would vary from, like, first it would be 0, then it would be 2, then it would be 3. So this likewise. So now every time you are checking if the node which you are getting from this loop is visited or not. If it is not visited, then you are pushing it into the queue along with the current node as its parent, okay. And if it has been visited, then we are checking if the node is the parent or not. If it is not the parent, then we are sure that there exists a loop in the graph. Otherwise we are not doing anything, and in the end, if there does not exist any loop, we are returning false. So is it clear now? Hello. Hello. Who asked the question? Hello. Hello, is it clear now? अरे यार बोलो कुछ। किसी को है अभी भी जिसको डाउट आ रहा हो या समझ में
No,
नहीं आया हो?
no, sir, it's clear. You can proceed. I guess he is not in the meeting right now.
ओके, देखो यार अगर कोई डाउट आ रहा हो तो पूछ लेना, मतलब ये मोस्ट इम्पोर्टेंट पार्ट ऑफ योर इंजीनियरिंग इज दिस डीएसए एंड द कोडिंग. If you skip it, then you won't be doing anything at the end of this course. You have to take it seriously. क्योंकि थ्योरी करते करते कोई फायदा नहीं होगा, एट द एंड तुम्हें कोडिंग तो करनी पड़ेगी. और ये जो तुम एल्गोरिदम्स पढ़ रहे हो उन्हें इम्प्लीमेंट करके तुम्हें प्रॉब्लम सॉल्व करनी पड़ेंगी. तो अगर किसी को डाउट है तो बता दो, वरना फिर मैं नेक्स्ट क्वेश्चन पे प्रोसीड करता हूँ. चलो ठीक है, दूसरा क्वेश्चन देखते हैं. अच्छा, अब देखते हैं अगर हमें साइकिल डिटेक्ट करनी है इन द डायरेक्टेड ग्राफ. तो फर्स्ट थिंक लाइक that parent approach, will it work in this directed graph also? या हमें कोई नई अप्रोच सोचनी पड़ेगी? बताओ, कोई तो बताओ.
नई अप्रोच
किसी को लगता हो? हम्म.
Probably new approach. Maybe we have
Parent
to
approach
modify
will
the
not
old
work
approach.
here
क्यों क्यों जो मना कर रहे हैं कि वो सेम अप्रोच नहीं काम करेगी, मतलब इस ग्राफ में उन्हें कुछ दिख रहा है या फिर जस्ट रैंडम गेस?
because ये डायरेक्टेड ग्राफ है तो 5 का पेरेंट बस 4 है, 3 इज नॉट अ पेरेंट ऑफ 5.
नहीं नहीं, अगर इसको देखोगे केवल 3 4 5 को.
So then for this one, the old approach will work.
यस यस, तो फॉर विच पार्ट द ओल्ड अप्रोच वुड नॉट वर्क?
So for this, suppose we start at 1. We start looking for cycles at 0 or at 1. Then we'll have a problem because it's a directed no. Like from 1 we can't move to 2, we can't move to 0.
No, no, we can handle it because we will traverse through all the nodes. We need a new approach here for the directed one. Okay, so it's clear to everyone. Then let's start with a new approach. What can we do? So, like, first, when you will call, like, suppose we are doing it with a DFS approach. Okay, so let me call the function D. So first you started with D0. Okay, now you move to D1. हम ऐसे ही तो करते हैं डीएफएस में. जैसे ही हम एक नोड पे गए, फिर एडजेसेंट नोड को देखते हैं, फिर उस पर डीएफएस चला देते हैं. एवरीबडी इज क्लियर विद द डीएफएस अप्रोच, राइट?
Yes.
So now you can't go anywhere from this. So this stack is collapsed now. Now you would start from 2. So D of 2, then you would go to D of 3. Okay, then you would go to D of 4. Then we will go to D of 5. Now then you would go to D of 3. Now you can see 3 has been visited here. Okay, so what can we do to check like if 3 has been visited before or not? So this whole thing is called the recursion stack. So you would check if 3 is there in the recursion stack. If you can find 3 in the recursion stack, then you would say like there exists a loop in the graph. If it's not there, then it's okay. So everyone got this approach? I will tell you how to track three or any node in the recursion stack, but let just tell me, is it clear to everyone? Like you would track each node if it is there in the recursion stack yet, and if it is not there, then we don't have any problem. Everyone clear about this?
Yes.
Okay, so now tracking this node in the recursion stack is very easy. So like you track nodes with the visited array, right? You would just make an array with recursion stack. So what we will do, so like this is your D of 2. So we would mark that 2 to true, like it has been visited and it's there in the recursion stack. Then we move to 3. Then we will mark it true as well because it's there in the recursion stack. Now we will mark 4 to true, then 5 to true, and then when we are coming to a node, we would check if it is there in the recursion stack. So once I reach 3, I would check if 3 is there in the recursion stack. So you can see it's true here. So we will get to know there exists a cycle in the graph. And one thing is more clear, you need to set it off also while we are backtracking. So like if suppose it would have not been 3 and this graph is moving backward, so we would set 5 to false, then we would set 4 to false, then we would set 3 to false. So you all guys are familiar with recursion, right?
Yes.
You have the basic idea, na? How recursion stack works, how recursion tree goes, like. Is
Yes.
it clear to everyone, like recursion thing? Because if it is not clear, you will need to make it clear, because sir told me that currently he's teaching you dynamic programming, and you need a very sound knowledge of recursion for that topic, and in trees also. So if anybody is feeling like how these things are going in the recursion, so you need to get your recursion good. So let us see the code. So this is the approach. Like now the question which can be framed. So this is a question on the lead code. So the main thing is used here, detect cycle in the undirected graph. But the question which is there is, so the question here is like there are some number of courses, and you have to take the 0 to number of courses minus 1. So you can represent these as nodes. So 0th node, first node, second node. Okay. Now you are given an array of prerequisites, and it is saying you can start course AI only after you have done BI. So you can assume it as a directed edge. So like after BI only you can do AI. So you can represent it like, so like there are courses. So suppose the example which they have given here. So 1, 0 is a prerequisite and there are 2 courses. So you can represent it like this. Like there is a node 0 and there is a node 1, because there are 2 courses. So 0 to n minus 1 nodes. Now it is saying that you can do 1 only after you have done 2. Only after you have done 0, you can take 1 only after you have done 0. So you can represent it like this. Okay. So sorry, reverse that should be there. After 0, you can do 1. now here you need you are given that. So first I would make the adjacency list. So here this is your visited array, and this is your adjacency list. So here I am creating that adjacency list. So you can just focus on this ADG for now. So your ADJ is the adjacency list, and here I am running that. So if the current node has not been visited, we are checking for cycle. So I am passing the node, that visited array, that recursion stack which I was talking about. It is just a vector like your visited one, and I have initialized all the nodes to false. Okay. Now, as soon as you enter the check for cycle, you would set your recursion stack to true. So it is saying that now uh, current node is there in the recursion stack. Then normally, like you do DFS, you would go through all the adjacent nodes and check. If the node has not been visited, then you would run the DFS on that adjacent node. If the node has been visited, then you would check if it is there in the recursion stack. If it is there, then you would return true that there exists a cycle in the graph. Otherwise, you can see like after we have run while we are backtracking. So once you have run this code and you would come out of this, you are in the backtracking phase. So then we are setting this false, and we are returning false if there is no cycle in the function in the graph. So everyone is clear how recursion stack is working and how our old approach was not working in this graph, and how did we use recursion stack here. कुछ भी डाउट हो पूछ लो, मतलब कोड में डाउट आ रहा हो, अप्रोच समझ में नहीं आई हो. सबको आ गया? हेलो हेलो, अरे बोलो यार कुछ. एम आई ऑडिबल? मेरी आवाज आ रही है किसी को?
Yes.
समझ में आ गया सबको? कोई डाउट नहीं है? कोई भी बताओ.
Sir, please repeat your question.
I'm saying if you can do this problem with BFS, like we used DFS approach here, so can we do with BFS also? बताओ yes या no. कर सकते हैं, वो तुम्हारे ऊपर है. तुम DFS अप्रोच यूज कर लो या BFS अप्रोच यूज कर लो, दोनों अप्रोच से हो जाएगा ये क्वेश्चन. ठीक है, तो एक और क्वेश्चन करते हैं. अब देखो ये वाला क्वेश्चन जो है ना, ये अमेजोन में पूछा हुआ है, तो थोड़ा अगर तुम फोकस करोगे तो ज्यादा अच्छा रहेगा इस क्वेश्चन पे. चलो ये वाला क्वेश्चन देखते हैं. देखो क्वेश्चन ये कहता है, हमारे पास एक मैट्रिक्स है. ओके. और ये क्वेश्चन बहुत इजी है, मतलब BFS अप्रोच लगाकर बहुत इजीली हो जाएगा, बट हल्का सा सोचना है इसमें. तो सपोज ये तुम्हारा एक मैट्रिक्स दिया हुआ है तुम्हें, ग्रिड. और इसमें ये नंबर्स हैं 0, 1 एंड 2। मैं भी बताऊंगा ये क्या रिप्रेजेंट करते हैं। हाँ, तो 0 जो है वो तुम्हारा एम्प्टी सेल है। 0 इज योर एम्प्टी सेल। 1 इज योर फ्रेश ऑरेंज। ठीक है, तो 1 रिप्रेजेंट कर रहा है कि उस सेल में एक फ्रेश ऑरेंज रखा है। और 2 जो है वो बताता है कि वो एक रोटन ऑरेंज है उस सेल में। ठीक है, अब ये देखो, अब हमें ये बताना है कि मिनिमम टाइम में, वो मिनिमम टाइम जिसमें इसमें सारे जितने मैट्रिक्स में जितने तुम्हारे फ्रेश ऑरेंजेस है ना वो रॉट हो जाएंगे, तो मिनिमम टाइम बताना है तुम्हें उसका, कि कितना मिनिमम टाइम लगेगा कि वो सारे फ्रेश ऑरेंजेस सड़ जाएंगे। अब वो सड़ कैसे रहे हैं, क्योंकि ये जो तुम्हारा रोटन ऑरेंज है ना, ये तुम्हारा इन 4 डायरेक्शन में जो भी फ्रेश ऑरेंज होगा उसको इन्फेक्ट कर देगा। ठीक है, क्वेश्चन समझ में आया सबको? हेलो,
Yes, sir.
Yes.
क्वेश्चन समझ में आ गया? क्वेश्चन में तो कोई डाउट नहीं है ना?
Minimum time for what exactly?
Minimum time under which all the fresh oranges are rotten. So, like here, your 2 is your rotten orange. So, for at unit 1, it would rot this fresh orange, and this fresh orange. So,
The
if
total of 2
I
time will be.
no, simultaneously. So, at t is equal to 1, these 2 oranges have been rotten.
At t equal to
Got
2,
it?
the next orange will be rotten. That is
Yeah.
the total
So
of 2. Total time 2.
you are telling about the whole grid, okay? Right?
Yes.
Okay. Then, yeah. You would take it would take two time equal to 2 units to rot all the oranges. So let me give you a hint. We would use BFS here. So if someone can come up with an approach. One more hint, like in the previous question, we were not just pushing the node, we were pushing the parent also. So here also we won't be pushing only the node, we would be pushing something else alongside the node in the queue, and the question will be done with BFS. Anyone, if you are having any approach, it needs not to be correct, you just try, like what can you use here using BFS?
We start from the first node which has 2, and
Okay.
then with in the first time for t equal to 1, we do BFS and then change all the adjacent nodes to 2. The ones with which have 1,
Okay.
they will become 2. And we'll do this for all the nodes which have 2 in them.
Which have to the okay.
And this will do recursively until there is no 1 left. We'll count the number of ones first, and after that we can do this.
No, your approach is right, but we don't need to count number of ones here. So let me tell you how would we approach this problem. So like this is your grid. Now, so first what we would do, we would check the grid, that what are the elements which are the cells which are having two, because we need to concentrate on the rotten oranges first. Okay, so what we would do, we would have a queue. So in the queue we will have all the cells which have the rotten oranges. So like this is your 0 based indexing I'm using here. So your 0, 1 is having a rotten orange. Okay, and at the starting we are using 0 for the time. So I was telling you this the whole thing will be stored in the queue. Now the second two we are having here is here. So what is the index here? 1 0 1 1 1 2. So second two is there on 1 2. Where is the third two? So third two is here. So it's there on 2 0. Okay, and then the fourth two is there here. So 0 1 2 0 1 2 2 2 is the cell position. Oh, it is 0. I just okay. So now, so first we stored all the cells which are having 2 in there, and the starting time is 0. So this is your starting time. So everybody is clear till now?
Yes.
Yes.
Oh, okay. So now this is your queue. So first we would take out this element. Okay, and now like we are focusing in this two. So I would check in all the 4 directions. So here I would check. Now, what would I check? What would I check for? Like if there is a 0, if there is a 1, if there is a 2. So what should be the condition? Like if there is a 0, or if there is a 1, or if there is a 2, or if there is 1 or 2, then I would convert it to anyone. अरे जैसे अभी करंट नोड तुम्हारा यहाँ पर है, ठीक है। अब तुम देखोगे चारों डायरेक्शन में, चारों डायरेक्शन कौन सी पॉसिबल है? यहाँ पर है, यहाँ पर है, नीचे है और ऊपर है, ठीक है। अब ये बताओ, यहाँ पर जैसे 0 है, क्या मैं यहाँ पर भी 2 कर दूं?
No.
बिकॉज वो एक एम्प्टी सेल है और वहां पर तुम रीच नहीं कर सकते, मतलब वो कोई लॉजिकल नहीं है कि वहां पर तुम 2 करोगे, ठीक है। अब अगर यहाँ पर जैसे 2 है, जब तुम यहाँ करंट नोड पे हो और यहाँ पर 2 है, तो भी कोई सेंस नहीं बनती है, क्योंकि यहाँ पर तुम मान लो यहाँ पर टाइम था 1, और तुम यहाँ पर उसको इंक्रीमेंट करके कर दोगे 2, जबकि वो पहले से ही ऑरेंज रोटन है, तो तुमने यहाँ पर फालतू का टाइम लगा दिया, ठीक है। तो हम केवल वहीं उन्हीं सेल्स को कन्वर्ट करेंगे जहां पर 1 है। इतनी बात समझ में आती है सबको?
Yes.
किसी को डाउट हो कि भाई जहां पर 2 है हम वहां क्यों नहीं कर रहे? ठीक है, तो अब जैसे करंट नोड तुम्हारा यहाँ पर है, तुमने साइड में देखा यहाँ पर 1 है, तो हम क्या करेंगे? अभी देखो यहाँ पर है टाइम 0, तो ये तो बाहर हो गया। अब मैं क्या करूंगा, हम क्या करेंगे, इसको तो 2 बनाएंगे, एक तो इसको कर देंगे 2, और क्यू में जो पास होगा वो पास होगा तुम्हारा इसका इंडेक्स, तो 0 0 0 1 0 2, एंड टाइम वुड बी 1। हाउ डिड दिस 1 कम? दिस 0 + 1। ये समझ में आया ये 1 कैसे आया यहाँ पर? किसी को डाउट हो कि ये 1 कैसे आ गया? ओके, नाउ we would check for this one. So here also there is a 1. So I would store 0 0 and यहाँ पर क्या होना चाहिए बताओ कोई? यहाँ पर क्या लिखूं? 2 3 0 1 क्या लिखना चाहिए यहाँ पर?
2.
Why?
If it runs simultaneously, it is 1.
Yeah, because I am telling you step by step, like now it is checking here, it is checking here, but these things are happening simultaneously. Simultaneously, it is checking at time t equal to 1, it is checking in all the 4 directions. So the time which it took to rot the oranges, just 1 unit we can add in this time. So we would get the time which this orange took to get rotten. So now here we would add 1. Okay, then here it is 0, so we would do nothing. So this part has been done. So now this would come out 1 2 0. So 1. Now it would check if above 1 is 1, no, it has been rotten to 2. Now the below one is also 2, and this side it has 0, so we won't do anything. Now we would come to this 2. Now this 2, it would check, okay, now this side it has 1. So what will it store in the queue? Someone tell me. And anyone, what should I write here in these two places?
1,
We are
comma
storing this element.
1,2.
1 comma y2.
1 comma 1.
1, comma 3.
Okay. So whoever told this one, just tell me from where did this one come? Like
This is the
current,
first step, so time is 1 now.
no. The crux is you are working on this node.
Incremented from 0 to 1.
Yeah, because you are working on this rotten orange, okay? And you would increment the time which this orange took to get rot by 1, and then you would get the time which this orange took to get rot. तो देखो जितना टाइम इसको लगा, इसको मान लो t टाइम लग गया रॉट होने के लिए, तो नेक्स्ट यूनिट टाइम में मतलब t+1 टाइम में ये भी रॉट हो गया, है ना? प्रॉब्लम कहती है कि हर यूनिट टाइम में रॉट हो रहा है, तो अगर ये टी टाइम में रॉट हो चुका है जो मेरे पास पहले से स्टोर्ड है यहाँ पर, तो अगर मैं +1 कर दूं तो मेरे को इसका टाइम मिल जाएगा कि ये कितने टाइम में रॉट हुआ है। इस चीज में किसी को प्रॉब्लम है? हेलो हेलो, अच्छा देखो यहाँ पर हम इस वाले ऑरेंज की बात कर रहे हैं, ठीक है? हेलो,
Yes.
अब देखो इसको रॉट होने में कितना टाइम लगा, यहाँ पे मैंने क्या लिखा है 0। अब मैंने बोला है कि 1 यूनिट टाइम में रॉट कर रहा है, तो ये इधर देखेगा इस साइड में, तो ये ऑरेंज रोट होगा। अब इस ऑरेंज को रोट होने में कितना टाइम लगेगा? 1 यूनिट ऑफ टाइम। अब वो 1 यूनिट ऑफ टाइम किसके रिस्पेक्ट में देखोगे? इसके रिस्पेक्ट में, क्योंकि यही तो इसको रॉट कर रहा है। तो इसलिए मैंने यहाँ पर इस 0 में +1 किया है, तब ये 1 आया है यहाँ पर। इसमें किसी को प्रॉब्लम है? एक बार बता दो, क्लियर ना हो, डाउट आ रहा हो, या तो डाउट आ रहा होगा या क्लियर होगा, कुछ तो बताओ।
क्लियर।
क्लियर है bro.
देखो ऐसा मत बोलना, क्योंकि ये मतलब अच्छा क्वेश्चन है, ये अमेजोन में भी पूछा गया है, माइक्रोसॉफ्ट में भी पूछा गया है। और मतलब तुम्हें ऐसे ही इम्प्लीमेंट करना होगा जैसे बीएफएस बहुत एक मतलब बहुत जल्दी वो ग्राफ वगैरह में जहां पर भी तुम्हें मिनिमम वगैरह के बारे में पूछा जाएगा वहां बीएफएस लगेगा पक्का। तो अगर किसी को कोई डाउट आ रहा है तो अभी बता दो, मैं अच्छे से एक बार और एक्सप्लेन कर दूंगा जहां भी डाउट आ रहा होगा। क्लियर है सबको? चलो फिर कोड देखते हैं, क्लियर है तो। अच्छा ये रहा, देखो ये तुम्हारी ग्रिड है जो हम बात कर रहे हैं, सबको दिख रही है ये, या जूम करूँ थोड़ा? दिख रहा है सबको पूरा?
यस।
तो ये तुम्हारा ग्रिड हो गया। अब हमने नॉर्मली जैसे हम बीएफएस लगाते हैं एक क्यू बना ली। अब देखो हम क्यू में तीन चीजें डाल रहे थे, एक तो सेल के इंडेक्स और टाइम, तो इसलिए मैंने यहाँ पे वेक्टर लिया है एक। ठीक है। अब हम कुछ नहीं कर रहे, हम नॉर्मल उस ग्रिड पे ट्रेवर्स कर रहे हैं पहले, और जहां जहां तुम्हारा जो है वो रॉटन ऑरेंज है उसको स्टोर कर रहे हैं क्यू में, और इनिशियली टाइम 0 लेंगे। ठीक है। अब नॉर्मली जैसे बीएफएस लगाते हैं, जब तक क्यू एम्प्टी नहीं हो जाती हम वाइल लूप चलाएंगे। अब देखना, यहाँ पर हमने ये टेम्प में स्टोर कर लिया वो वेक्टर जो क्यू में था। अब देखो ये तुम्हारी करंट रो हो गई, ये तुम्हारा करंट कॉलम आ गया और तुम्हारा टाइम आ गया। ठीक है। तो जैसे यहाँ पर था, मान लो कि इसको रॉट होने में 5 यूनिट लग रहे थे। ठीक है। मान लो इसको रॉट होने में 5 यूनिट लगे हैं अभी तक, ये टाइम है वहां पर। अब मैं क्या करता हूँ, अब मैं चेक करूंगा कि भाई अब वो 4 डायरेक्शन में देखेगा, तो 4 डायरेक्शन में करंट रो में कॉलम +1, मतलब कि इस डायरेक्शन में कॉलम +1 हो गया, रो वही है। तो उसको यहाँ पर सपोज करो 1 मिल गया, तो हम क्या करेंगे, यहाँ पर टाइम +1 के साथ पुश कर देंगे। एक तो वो इंडेक्स और टाइम +1, मतलब अब यहाँ पे 6 पास हो जाएगा। और उस ग्रिड में हम 2 कर देंगे, क्योंकि अब वो जो ऑरेंज है वो रॉट हो चुका। और ये हम इस सेफ जो हम चेक कर रहे हैं वो हम इसलिए चेक कर रहे हैं कि आउट ऑफ बाउंड ना चला जाए, मतलब जो इंडेक्स है, क्योंकि देखो यहाँ पर जैसे अगर यहाँ पे देखोगे तो इसकी अपर वाली डायरेक्शन में तो कुछ है नहीं ना, वो आउट ऑफ बाउंड चला जाएगा। तो इसलिए वो चीज चेक करने के लिए कि तुम्हारा इंडेक्स सही होना चाहिए, तो इसके लिए हमने इस सेफ लगाया हुआ है। देखो अब तुमने चेक कर लिया कि अच्छा राइट वाली डायरेक्शन सेफ है, हाँ सेफ है, तो हमने क्यू में पुश कर दिया। फिर अब रो +1 और कॉलम, ये बताओ ये कौन सी डायरेक्शन में देख रहा है करंट नोड से?
राइट।
राइट। एक बार ध्यान से देखो, ये रो है,
बॉटम
रो +1
लुकिंग
की
डाउन।
रो। हाँ बॉटम में। अब अगर वो सेफ है उसको मूव करना वहां पे, तो हम क्या करेंगे, टाइम +1 पे 1 से इंक्रीमेंट कर दिया टाइम, और उस ग्रिड को 2 डिक्लेयर कर देंगे कि वो रोट हो चुकी है। अब फिर तुम चेक करोगे इस डायरेक्शन में, इसका बताओ ये कहाँ पे देख रहे हैं, रो और कॉलम -1?
लेफ्ट।
लेफ्ट में देख रहे हैं। अब ये बताओ ये रो -1 और कॉलम?
अप।
हम्म तो अभी देखो हमने केवल यहाँ 4 डायरेक्शन देखी, क्योंकि क्वेश्चन में मेंशन था कि केवल 4 डायरेक्शन में रोट हो सकता है। अगर ये डायगोनल भी अलाउ करते तो हमें फिर वो भी ऐड करने पड़ते, तो फिर हमें 8 डायरेक्शंस में देखना पड़ता। जैसे यहाँ पर एक डायगोनल भी इंक्लूड हो जाते चारों, ठीक है। तो ये क्वेश्चन समझ में आया तुमको कैसे किया है? किसी को कोई डाउट अभी भी कोड में या फिर अप्रोच में? देखो क्वेश्चन इजी है, बट वही है कि तुम्हें क्या बोलते हैं कि एल्गोरिदम अप्लाई करनी आती है या नहीं। बीएफएस में कुछ मॉडिफिकेशंस हुए हैं और हो गया क्वेश्चन ये। और ये हो रहा है कि जब भी ग्राफ का प्रॉब्लम आएगा ना और तुमसे कुछ मिनिमम चीज मांग रहा होगा, तो उसमें बीएफएस यूज होगा 100%। अच्छा चलो, अब किसी को डाउट नहीं है तो एक और प्रॉब्लम देखते हैं, लास्ट वाली। चलो अच्छा, नंबर ऑफ आइलैंड्स देखते हैं। देखो इसमें भी मतलब सेम सी है ये, थोड़ा सा इसमें दिमाग लगाना, मतलब ये सिमिलर है इस रोटन ऑरेंजिस से। देखो कितना कितनी आसान होगी, इतना सा कोड है। तो देखते हैं ये प्रॉब्लम क्या है पहले तो। देखो इसमें भी एक मैट्रिक्स दी हुई है तुम्हें, ठीक है। अब ये तुम्हें वन है, केवल दो वैल्यूज यूज हो रही हैं, वन वन और जीरो है केवल, ठीक है। अब देखो तुम्हें क्या करना है, इसमें ना तुम्हें बताना है कि नंबर ऑफ आइलैंड्स। अब आइलैंड्स क्या है, ये जो जीरो है ना, ये तुम्हारा रिप्रेजेंट कर रहा है उस वाटर को। तो लाइक इफ दे आर कंसेक्यूटिव वन, तो जैसे ये दो वन है तो तुम इसको एक आइलैंड मान सकते हो। फिर ये जीरो आ गया बीच में, और फिर ये एक और आइलैंड बन गया, तो यहाँ पर आइलैंड हो गए दो, ठीक है। अब तुम्हें ऐसे ही बताना है कि कितने आइलैंड बन रहे हैं, तुम्हें ग्रिड दी जाएगी। चलो पहले ये सोचो कि इसमें क्या लगा सकते हो, मतलब प्रॉब्लम सबको क्लियर हो गई है? हेलो,
Yes.
Yes.
प्रॉब्लम में तो कोई डाउट नहीं है ना किसी को?
No.
Yes, sir.
एक बार और क्लियर करते हैं। जैसे अब यहाँ पर तुम वन पर आ गए, अब जैसे यहाँ पर वाटर है, यहाँ पर वाटर है, यहाँ पर वाटर है, तो ये केवल एक आइसोलेटेड आइलैंड हो गया, ठीक है। अब जैसे वन से तुम इधर देखोगे तो यहाँ पर वाटर है, तो तुम यहाँ तो नहीं जा सकते। फिर यहाँ पर देखोगे, यहाँ पर वन है, तो मतलब आइलैंड ही है, तो ये एक तुम एक आइलैंड की तरह ट्रीट कर सकते हो इसको। तो प्रॉब्लम अब क्लियर हो गई है बिल्कुल कि कैसे निकालना है, क्या पूछा है और हमें क्या बताना है।
Yes. First, we start from any of the ones. Then we
हाँ
do BFS and see the all the surrounding ones. Make sure that all of them are visited.
ओके।
Once it is done, once we have no more ones in the surrounding, like we increase the number of islands by one, and then we move to the next one in this array or in this matrix.
ओके
In this way, we
सो
repeat.
ओके सो यू आर मेंटेनिंग अ विजिटेड एरे, यस, इज इट राइट?
Yes.
So you can do it like this also. So whenever you visit a node, you can make it zero also to make it count like it has been. So let me go
Yes, it
through
is
the code.
possible.
So
It will work.
hmm,
This will work.
so you can do this question by both the approaches. Either you can use BFS or DFS. So I have used DFS. So how would we do it using DFS? So first you will start from this. So like you are running a loop from this matrix. So first you come at this. So it has not been visited yet. So actually we won't check here that it is visited. We would check if there is a 1 in the grid. So there is a 1. So I would apply DFS here. So in this also I can move in 4 directions: upper one, left, right, down, sorry, left,